KNN saves any W and B parameter? No. Does KNN save something? Does it save something? Only number of groups? Data points, not just number of groups. Okay, it saves those as well. So again, I just wanted to test few of you, whoever is answering. So we need to find optimal value of K, and I will show you how to do that. What is the next thing left? Tell me. Practical of cross validation. Correct. Okay. Practical of cross validation. And I will show you in the same data set. It is again just single line of code because we know the theory behind it, the concept behind it. It is just we are talking about implementing it. Okay. Then what else is left? What else is left? Practical of SVM. What is SVM? What is SVM? Support vector machines. Okay. Then in support vector machines, we also have kernels. So the practical itself always utilizes some kind of a kernel, or the three kernels we already know, right? Guys, what are the three kernels? What are those three kernels? Linear. Then next one is, what is the next kernel? Polynomial. Short form of the last one. Guys, don't write RGB. RGB is the LED color. It is not RGB. What is that? It is not RGB. Tell me. RBF. Don't say RGB, okay? See, what will happen if you answer something like that in the interview? Sir, I want to apply a RGB kernel of SVM. Okay? Is everyone clear? Don't say the wrong thing. Just say, I don't know. That is better. But I know you're just telling in the class. Sir, in syllabus, SQL is written when guys, Sandhya SQL is already covered. Guys, is SQL covered? SQL is covered long back. In the Python, we have covered, 3 months back, Sandhya. We have seen multiple things. What kind of SQL we have seen? MongoDB, Postgres, and also one more thing. What did I show you? Supabase, Postgres. All right. We have already covered, guys. We are going line by line in the syllabus. And I will also show you just a quick example of hyperparameter tuning using grid search. Again, it is kind of 5-6 lines of code. This is 5-6 lines of code. This is 2-3 lines of code. This is 15-20 lines of code. So we are going to do all of that. And if time permits, then I want to start with another algorithm. This is optional for today's one, but I want to do that because I want to cover machine learning whenever we have time, right? Naive Bayes theorem. Okay. Guys, did we cover Bayes theorem in the statistics? Did we cover Bayes theorem in the statistics? Do you guys remember something like this? Probability of A given B. Yes or no? Probability of A given B, then we write some kind of a formula for that. Okay, that is the basis of this naive Bayes algorithm. So we are going to cover that, but not the coding part. And also Guys, once we covered the SVM, we already covered the SVM. Everything we are going to do is going to be very, very, very simple. This is also very fun algorithm to learn, just like K nearest neighbor. All right. So we will try to cover this one. Naive bias ML. Okay. It's conditional. Yes. All right. Is everyone clear with today's agenda? Everyone, yes or no? Okay, great. So, a lot of practicals. Almost everything is going to be practical in today's class. And it requires understanding of the previous algorithm. I'm not going to talk about the algorithm again. This is the previous class. This is the notes of previous class where we were working with iris dataset. I hope everyone knows what is iris dataset. Guys, what is iris dataset about? What iris dataset is about? Diabetes? Uh, guys, eyes. Were you even attending previous classes? Eyes and diabetes is the very wrong answer. Guys, iris is a flower. What is going on today? Did you guys enjoy your Sunday too much? Yeah, it is a flower which consists of three different, what is those species of iris flower? Setosa, versicolor, virginica. And this particular data set contains their sepal length, sepal width, petal length, petal width. So using these four features, we categorize Setosa, versicolor, and virginica. Yes. Are we clear now? So what we did in the previous class, we loaded this data set. I need to select the kernel. Loaded this data set. Then what we did, we created a copy of it, data set. We check how the data set looks like. Then we created the target names. We extracted the target names and then mapped it to a dictionary so that later when the model predicts 0, 1, 2, for the predict function, we can get Setosa, versicolor, virginica. Yes. Then directly, because all of them are numerical, we just split it into train and test with a random state of 42, test size of 20%, training of 80. Everyone know what is stratify? I am hoping everyone knows what is stratify. I'm not going to explain this part again. So here we splitted the data. Then we created an object of standard scalar, then did the fit transform on train, and then transform on text. Everyone knows this concept of fit transform and transform. Yes. Then we created k nearest neighbor classifier with k equals to 5. We fitted the model of train and y train. This is a scaled version of the data which we just converted here. Okay. That is scalar dot fit transform and then dot transform. Yes, correct. Okay. Sir, here, guys, when do we use transformer and pipeline? I showed you a different method, but internally we are doing this part of things, yes or no? Internally, we are writing these functions, but in a pipeline. The main point of transformers is when the data set becomes much more complex, then you need to do a lot of things. And also, currently, I'm only doing standard scalar. I only need one artifact to be saved that is standard scalar. When I have lot of artifacts, sometimes one hot encoder for a particular column, then categorical from some other column. There are a lot of different kind of transformation I'm doing on my data. So I need to save lots of those transformation as a pickle file or as a job.lib file. To not do that, then we create the transformers. Are we clear? So because this thing is simple, I don't want to complicate it. Then we created a k nearest neighbor classifier of k equals to 5. Then we trained the model. Then we predicted the model on both train and test. Okay. We checked the accuracy score. We were getting 97% accuracy and 93% accuracy on the test set. Then we created a predict method, which takes this length, the actual input that user is expecting in centimeter. Then we do the transformation. Then we predict it. I hope everyone knows now what we did in the previous class. Is everyone clear? Is everyone clear? Okay. So let's divide few parts of it. Here I will say that this is training. Everyone, please keep all your focus in here. Okay. This is training where we are doing the evaluation. Here we are doing the evaluation. Okay. Here we are doing the evaluation. And then this is prediction function. Okay, this is prediction function. So what I'm going to do, I hope everyone remembers the cross validation. So first, just a small recap on what was cross validation. Okay, because I'm going to use it now, and also using cross validation, we are going to use this how to select the optimal value of k. Okay, so I will start with cross validation. I'm not going to repeat things. What I'm going to do is just going to introduce you again. Okay, because I'm expecting everyone remembers what is cross validation. So the example which I gave in the previous one, let's suppose we have all the data, that is A, B, C, D, E, F. Okay, this is our data set. And if I select my k fold, that is a value of k is equals to 3, it means I want to create 3 folds of a data set. The first fold, for example, okay, k fold, and the training data which is going to present here, and then the test data. Just for an example, in the first fold, I will have, let's say, C, D, E, F. Then whatever is left will be in A, comma B. Okay. Now tell me, is A, comma B should be present in the next fold? Should A, comma B be present in the next fold? No, because cross validation, this cross validation ensures that every part of the data set should be a part of test set. No, it's not about data leak here, because everything is going to be used separately, right? We will create a model from this one, create a model from this one. So it's not about data leak here. It's about, we want to test something every time, a different kind of a test set. We don't want to test the same thing. If you're testing on that same thing, then the other data will be same. Whatever data is left, we will left with the same thing. So cross validation says that we are going to have all the test set. Okay, we are going to have each and every value in the test set at least one point in a time in one of the folds. So let's suppose in the second fold, I am saying that CD should be present. So I will get A, B, E, F. So A, B, C, D. Let's suppose EF is present in the test set. Then in the third fold, I will get what? A, B, C, D. This is my fold 1, fold 2, fold 3. So whatever my data set is, when I mention the value of k, I will get that many number of data. Are we clear? Are we clear? Are we clear with the revision, everyone? Yes, Shiv. Based on the fold, it will decide how many numbers will be there. Okay. Okay. Each data point will be a part of testing once. Correct. K fold means this is the data set. We are creating a different folds of it. Every time a different set of train, different set of test. Fold 1, different set of train, different set of test. That is what fold is. Okay. So now what I'm going to do, I'm going to use cross validation. So let me show you one thing. So what I'm going to do, now we are talking about, everyone focus. Sir, how do we calculate 2 for test? What do you mean by 2 for test? Shape, this is just an example. Internally, a function is there, it will divide it like that. Shiv, why do we even care? If we have 2 data points, one is going to be train, one is going to be test. What are we going to do? Next time the train and test, we are going to interchange it. It can only have 2 possibilities. Don't always be in the edge case. Okay. It's a function, guys. It is not a machine learning part. Okay. So before evaluation, after evaluation, let's create the next part. That is optimal value of K. Okay. Finding optimal value of K. Now inside it, I'm going to create multiple sections. So there is something called as elbow method. Okay. There is something called as elbow method, which we use with an algorithm called as k-means clustering. Okay. This algorithm uses something called as inertia, which we will talk about when it's about this class, k-means clustering. I'm not saying k nearest neighbor. It is a different algorithm. So in k-means clustering, the clusters itself has centroids. Okay. The data points have those centroids. And from those centroids, we create those inertia. What we do, we kind of plot something like this. I'm just giving you an introduction. Okay. Kind of we plot something like this. Okay. And in x-axis, we have number of k. In y-axis, we have inertia. So we will see something like this. Okay. So let's suppose this is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So tell me at which point, at which value of k you are able to see a large shift. At which point of k you are able to see a large shift. From which point? From which point you are able to see. So we can say that around 4, when the value of k is equals to 4, after that we are able to see a very low value of inertia. Previously it was decreasing by some factor, but now it is kind of going in a different direction, or it is very different. Okay, so we can say for guys, value of k. Did I say 4.5 is a value of k? No. K value. K means clustering. There is also concept of k. So it is a whole number 4, 5, and others. Okay, so it is around 4 to 5. So this is nothing but we call as elbow method. So using this kind of a graph, we will train a model with 4. We will train a model with 5. We will not do 1, 2, 3, 100. We will do multiples. We will train all the way from 1 to, let's suppose, 20. But which value is the best one? We will choose from graph like this. Are we clear? This is what we call it as elbow method. Are we clear? It looks like an elbow, a shape. We kind of uh, check whether it creates a shape of an elbow. We see a change in the angle. Are we clear why it is called elbow? Does it look like an elbow? Does it look like an elbow? Yes. So this elbow kind of shape, using that, we define the value of k. Is everyone clear what is the elbow method? Guys, are we clear? Great. Okay. But currently we are learning k nearest neighbor. K nearest neighbor does not have anything called a centroid. Did we learn anything called a centroid? Did we learn anything called a centroid in k nearest neighbor? No. So when there is a no concept of centroid, there is no concept of inertia. So what we are going to do, we are going to plot accuracy. Okay, we are going to plot accuracy with respect to, accuracy will be y column with respect to our number of k. And we will see which k value is helping us visualize the accuracy better. Because if I have 1 to 100 number of k's which I'm training, then what I will get? I will get lot of numbers. And from those numbers, yes, it is very easy to kind of check which one is having the maximum value. We can pick that. Yes, we can pick that. But let's suppose from k is equals to 17 all the way to k equals to 100. Okay, k equals to 17 all the way to k equals to 100. K17 accuracy is 98.8. K equals to 100, accuracy is 98.9. Which one will you pick? Which one will you pick? From the just the Python point of view, if we check the max, we will get K equals to 100. Yes or no? But if we have everything in the graph, if we have everything in the graph like this is accuracy. If we have everything in the graph like this, we know that K equals to 17 is kind of a computation factor. When a new data point comes, it will look for 17 neighbors and calculate the distance. But if K equals to 100, then the computation will increase or not? Computation will increase or not? Computation will also increase. So if there is a very small marginal from K equals to 17 and all the way 17, 18, 19, all the way till 100, we are in this accuracy range. Why not stop at the 17? And we can only decide that by looking at the graph. Yes or no? Graph will help us, yes or no? So we are just using a concept of elbow. We will not find any elbow, but we will just plot accuracy with respect to our K values. Are we clear? Are we clear? Great. Okay. So done. So what I'm going to do, I'm just going to write elbow method. It is not a elbow method, but elbow method to choose K. Instead of inertia or some other components, we are just using, let me mark with triple. Okay. Elbow method to choose K. So what I'm going to do, first, I am going to create wait. Okay. Yes. I'm going to create a list which will contain accuracy of the test set for multiple values of K. Okay. So K, I want to select from 1 to 20. Okay. 1 to 20. And for each range of this K, I am going to train my nearest neighbor. So nearest neighbor will take this K as the input. I'm going to train. So first of all, at the very first model, this KNN is going to have K value equals to 1. Then we are going to perform our fit and train of the model. So I will do KNN.fit. I am passing the X train and Y train just like the previous code. Just like the previous code. Okay. Fit and train. But now I am storing their accuracy values in a different place. Then what I'm going to do after fitting, I'm just going to predict it. Once it is predicted, then I will calculate their accuracy score. Accuracy is the method which we imported previously. We will get the accuracy. Then we will just append this accuracy. All right. So we will append this accuracy here. Let's run it and it's done. What we are going to do next is we are just going to plot how the accuracy looks like with respect to number of Ks. Why this prediction function is here? PLT. Okay, I have not imported the plot. So let me import it here. Are we good? See, around 2 to 5.5 or some kind of values, we are getting, there is no 2.5 or something, but it is a plot. It is showing you that this is 2, this is 3, this is 4, this is 5. So around 6, 2 to 6, we are having the same kind of accuracy. Then the accuracy is, see, when the value of K is around 1, we are getting the highest number. Then we are seeing this kind of a number. It's not a straight line, but it is increasing somewhere. But we are able to see that around number, what will be this number? This is 8. Around number 9. Around number 9, we are able to see there is somewhat increase here as well. Guys, can you see? This 9, there is some kind of increase here. This is the highest point from my point of view. Guys, can you see it? It is going little bit above the straight line. So around this, what is this range? What is this range? Guys, I can see this. What is this range? Around, see, if this is 12.5, this one will be 13. 13, 14, 15, whatever I will select, around 13, 14, 15, I'm able to get something. Yes. Yeah, y-axis, this is y-axis, this is x. This is the value of y with respect to corresponding x values. We are checking which one is the highest. So I'm able to find that value of around 13 is kind of giving me a good one, but it's not like 9 is a bad value. Arun is saying, can you increase the y-axis to 1 in the short interval ones? What is the accuracy values we are getting? They have to do a little bit of calculation. We'll do that. Arun, this is fine. You can do it later. Okay. So what I will do now, I have selected that just from looking at it, 13 k equals to 13 looks like a good value of k. As I mentioned, 13, 14, 15, 20, even 9 is not a bad number. All of them are giving us good accuracy. Yes, all of them are giving us good accuracy, but we picked 13. It's not like one of them is wrong. So this is via accuracy. Okay. You can also check which one is giving you less error. So if this is the accuracy, error will be just the proportional of it. So here, if you are calculating the accuracy test, you can also create something like this. I will show you. How are you saying good or not? Show one, because it is accuracy on the test set. Accuracy on the test set. The higher the accuracy with respect to particular k value, the better the model is. That's what we were doing always. Yes. So error rates. Okay. Ranga will talk about that. Okay. Yes. This is error rates. Okay. Now we can also note down errors. If you want to check how error looks like, guys, what is the formula of error? In terms of classification, error means when both of them are not matching is an error. Yes or no? When y prediction and y test are not matching, no, y hat minus yi is a different thing. If both of them are not matching, then it is a false. If both of them are matching, then it is a true. Yes. We are talking about classification, guys. It's not a regression problem. Then this is accuracy. Yes. Then what we are going to do, np dot mean. So I'm going to import numpy as well. Import numpy as np. Then np dot mean, we are just taking the mean of it. What is the error of this particular value of k? Y prediction and y test, if they are not equal, then it value will be true. If both of them are not equal, then it will be true. Then we will take the value of it. Okay, this will be error. Then what we are going to do, in error rates, we are going to append error. Just like the accuracy, we are just appending the error. So instead of this value, now we can also plot error. It's totally up to you. Let's plot error. Error will show you the opposite, because whatever the accuracy is, whatever is not correct will be the ones. You can see the 1, 1. When the value was 1, it is very low. When the value, it is just like opposite of this one. Yes or no? It's just the opposite of this one. This one was correct. This one tells you the false one. So you can see the values of the lower error rates are the correct ones. So you can check from here. Okay. I think the value of 9 is also very good value. So you can select anyone. Okay. So this is how to choose the value of k. But there are other methods. This is via elbow method. It's not an elbow, but similar to an elbow, we can also plot something like that. Now let's talk about the final part, that is cross validation. So what we will do with the help of cross validation, we will use cross validation to find best value of k. All right. We will find the best value of k. So what I'm going to do, that is the real part, guys. As I mentioned, when we have a static train and test, everyone, when we have a static train and test, and when we test the accuracy from the test set, Baiju, I'm telling you, this is one of the method to find it. It's not a method specifically for it, but you can use it to find it. The specific method of elbow was for k nearest neighbor, not for knn. All right. So in the previous one, we were having a constant, a static train set, a static test set. For every value of k we are testing on, we are calculating the accuracy of the test set. And from the previous classes, I told you that it might be possible that for some other cases of test, for some other set of test, we might get an accuracy of 50%. Yes or no? Because a test set is very different. So we want to test our model on multiple folds, and each fold will kind of gives you an example like a real world. We will kind of simulate something to showcase that in the real world we also can get a very weird value, a very weird test sample. So why not calculate multiple accuracies and then calculate a mean of it just to tell how good my model performance is? Yes or no? So instead of saying 98%, 50%, we will do average on all of those folds, and then at later we will calculate the accuracy. This is not a model, but just a way to tell how good my model is going to be in the real world. Yes or no? Tell me, everyone. So using same concept, it is not getting selected. Okay. Using same concept, now see what I am going to do. Using cross validation for optimal value of k. So what I'm going to do, I am going to select k equals to 10. K equals to 10. I'm talking about k fold. Okay. I'm going to select k fold value equals to 10. It means for a single data set, I am going to have 10 different folds like this. Yes or no? Each of them will have this is a single fold. Each of this fold is going to have its own train and test set. Is everyone able to understand? Then each of this test set is going to bring a different accuracy. Yes or no? And using the mean of it, we can get the average also. Average accuracy. Average accuracy. And we will, this particular model which we are getting from k nearest neighbor. We started with k equals to 1. We will do the k fold and train the model. Yes or no? For single value of k, we will get 10 different models. Yes or no? For single value of k, we will get 10 different values of accuracy. So for a single value of k, we will get its mean accuracy. For k equals to 2, we will get its mean accuracy. Whichever of this mean accuracy is having the highest score, we will pick that code. Highest score will get us optimal k. I hope everyone is able to understand now. Step 1, step 2, step 3, step 4, and this is step number 0. First select the K, then do all of those things. And this is step number 5. How is it different from elbow? Guys, the one which we were doing in the elbow, we were not using cross validation. This one which we are doing, we are not using cross validation. We only have a static train and test. A static train and test is only going to create one accuracy for a single test set. It might not predict the average test set for a different folds. Is everyone able to understand? So instead of getting a single accuracy for a single model, for a single value of K, we were getting a single accuracy. Now for a single value of K, we will get 10 different accuracies because we have 10 folds. For 10 folds, we will do the mean of it. So instead of counting on the accuracy, single accuracy, now we will be counting on mean accuracy for a particular K value. Is everyone clear now? Is everyone clear now? Just a different approach, but a more robust one. No, Ranga, cross validation never tells that I am avoiding overfitting. Cross validation is only used to check your model performance over multiple sets. Everyone, see this. What we did previously for small k in range of 1 to 20. For KNN, we applied this K and then we predicted dot accuracy. I'm just writing a non-Pythonic way, and this is giving us accuracy. Okay. X train, comma, Y train. Okay. Accuracy we will be doing on X test, Y test. That is, okay, Y test and Y prediction. Is everyone able to understand this? This line? This is not Pythonic, but everyone is able to understand this. For a single value of K, we will train the model, predict the accuracy, predict and then calculate the accuracy on Y test, Y prediction. Guys, you are saying didn't understand. I cannot shorten the class, right? I just showed you the code, guys. What is going on? Even after all of this dry run, is everyone able to read this? Is everyone able to read this? Okay. X train fold, comma, Y train fold, and just going to reduce it. What this particular KNN is going to bring, again, we are going to have, just wait. X test fold, and it is going to give you Y prediction fold. Okay. It is going to give you Y prediction fold. And then you are going to create accuracy score from Y test fold and Y prediction fold. You will get accuracy of that fold of that K. You will get accuracy of that particular fold for a particular value of K. So this is what I have written. It is going to be the same thing. And let me erase all of that. Okay. So previously, see this, for single K, what is the how many accuracies we are getting? Previously, for a single K, how many accuracies we were getting? We were getting single accuracy. Now, for a single K, for a single value of K, now we have cross validation fold data set. Cross validation fold data. So if my K fold value is equals to, if my K fold value is equals to 3, how many data set I'm going to get here? How many data set? I'm going to get 3 data. 1, 2, 3. Now that I have 3 data, how many models I'm going to create? I'm going to create KNN with a value of K. KNN with a value of K. KNN with a value of K. This set 1, 2, 3 has its own train and test data, yes or no? Each fold is having its own train and test data, yes or no? Yes or no? So each KNN model is going to create a different accuracy. Yes or no? Yes or no? So can I say for each value of K, for each value of K of KNN, for each value of K of KNN, I will get K fold accuracy, K fold times accuracy. Yes or no? So if my K fold is equals to that, so for each value of KNN, I am going to get K fold accuracy values. Or is this confusing, guys? K fold value was 3. For a single value, we were getting 3. So when the value of K is equals to 1, we will get 3 accuracy. When the value of K is equals to 2, we are going to get 3 accuracy. When it is 3, we are going to get 3 accuracy. For each of this value of K, now we are going to do average of this accuracy, that we will call it as mean accuracy. So instead of single accuracy, now we will be comparing that with mean accuracy of K folds. Are we clear? Are we clear? Same thing I've written here. It is going to do internally. Is everyone clear, guys? I'm not going to repeat it. Please say it right now. It was a very short thing. It is just a Pythonic thing. How can we decide number of k? The more you have, the more number of accuracy you will get, Ranga. The shorter you get, the shorter train test split you will get. The large number is good, but again, the computation will be high. So everyone, now see how I am going to do it. Focus. So what I'm going to do, I am going to store cross-validation scores in a list. Use 1000 if your data set is large enough. Ashish. But very computationally expensive. Right now, we are working with a data set of, if data set is in millions, then millions of models and other things it is going to create. We don't want that. Number of folds times the number of models. Okay. So it should be some kind of a not very large value. It's fine. 10, 20, 30, 50. It's fine. So see what I'm going to do for k in k range. Okay. Let's suppose I want to test in the range of, what was the previous range? Let me define. Our k range is equals to, I'm going to define range of 1 comma 21. Okay. I've defined it as a iterator. Then this will be the k range. Now let's implement it. Very simple, everyone. So for each of this k, I am going to create a model. See this. For each of this k, I will create a model first with that value of k. Yes, with that value of k, I'm going to create a model. So where is our k nearest? Okay, let me write it. I already have the code here. Why I'm wasting time? Is this part clear? Now within one line, we will complete the cross validation. So in cross validation, first I have to import the cross validation. Just wait, okay? Yes. We don't want train test split is already done. We want cross validation score. So using this cross validation score, we are going to pass the model which is going, we want to train. So in this cross validation score, the first argument should be the model. The second is what is my X and Y values. Okay. What is going to be my X and Y values? And then how many number of folds I want? I want 10 folds for a single X and Y. I want 10 folds of that. I already told you what meaning. And then the scores I want is the accuracy. I want accuracy of each of this fold. So for a single value of k, how many accuracy I will get? For a single value of k, how many accuracy I will get? I will get 10 accuracies of 10 different folds. Are we clear? Are we clear? So we will pass our X trained scale. We will pass our Y train. But do we need to split the data? Do we need to split the data here? Because it is already going to create a different train and test split. But still, if we want to do that, we can do that. But what I want to do, suppose I have not done any kind of a transformation. Okay. We already did the transformation and after splitting. Okay. Let's suppose I have not done the transformation. I will just pass X and Y, the original data. Because it is numerical, it will still work. It will work or not? It will work or not? It will still work. The gradient descent is going to have little hard time, but that is not our issue now. I'm telling you how to do it. Later, you guys can, before splitting the data, you guys can do the standard scaling. Yes. Or if you want to do that, I will do it now. See this. We don't even need, but if we do it on all, because we are doing here on all, and it is going to create, okay, it is fine. See, just for the sake of this one, to make it easy, what I'm going to do, I will pass the whole X and create the whole X scaled. Better? X scaled I created. Then here I will pass the X scaled, because internally it is going to create a lot of test set. The more data it has, the better it is for us. Because in this data set, we don't have a lot of data set. That's why I am omitting the X test split. Okay. X scaled and Y I have passed with a cross validation. I will get 10 score for each value of K. Okay. Then what I want to print this whole thing. What I want to print, I want to print what is the K selected, what is the mean in the scores. If you pass the mean, it will create you the mean average, mean accuracy. This will be the mean accuracy, and scores for each fold, fold 1, fold 2, fold 3, all the way till fold 10. We will get a list of each of this fold. Print is done. What I want to do next is whatever the scores which I am getting, okay, I want to append it to CV scores. That's it. Guys, is this code clear? Is this code clear? Just look at it. Very simple code. This thing is going to create 10 scores, each for a different fold. Instead of appending all the scores, we are appending the average accuracy to the CV score. This will be corresponding to index 0 will be a value of K and other things. So let's print it. Oh, cross validation not defined because I have not imported it. Now let's see. Zoom out. Nearest neighbor selected one. Mean score is 0.95. Check each and every accuracy. Let's see. This is all 10 folds accuracy when the value of K is equals to 1. When value of K is equals to 1 and fold equals to 0, we are getting 100% accuracy. But next one, in the next fold, we are getting 93%. In the next fold, again 100, again 93, again 86. So if we do the only single split, the accuracy value which we will get might not be the true accuracy, because we are able to see this kind of numbers as well. Yes or no? Yes or no? And then what we did, we just did the average. Now this is the average. What is the average? 95%, 95, 95, 94, 95. We can see a lot of the numbers. Okay. See all of them. Now, next part is we will just check which one is the best one. Using this K range values that we have. Okay. This K range. Where is our K range? This one. Okay. We are just checking np.argmax CV scores. This will give us the argument, the index of the maximum score, the best K. Okay. If I print it, say this, it will give you the index. Now, this is nothing but your best K value. Are we clear? Okay. So I will just print it, and this is your best K values. Where the accuracy is 96.67. Is it very close to value number 9? Is it very close to value number 9? Yes, it is. We can plot this CV scores against the K range, and we can also get this plot. For each value of K, what was the average mean accuracy of the cross validation? Smith, guys, if 8 is giving the best accuracy here, even is working. If you don't want even, if you want to go with the traditional method, which I told you that it should be odd number, then go with a 9. Okay. Or choose the second best. Just sort these values out and choose the second best if you think that is an odd one. But you can see value, it is giving, this is around 9. Where is that 9? 8. See, this is the value of 8. Cross validation is giving you different accuracy because it is the average of all the cross validation. Previously, 9 was correct. If you guys remember, 9 was giving us a good range. But when we talk about the cross validation, the accuracy looks too much zigzag. Yes or no? if you compare this plot with the plot that we have here, this plot looks very stable because the test set was always static. But when you change test set a lot, then your true accuracy comes and we are able to see something like this. So I can see 6 is also a good value. 8 is also a good value. Then this one, a 16 is also a good value. So this is how we select the optimal value of k in k nearest neighbor. In interview, a lot of people are expecting that you will just say a odd number or an even number, but a lot of people don't know how to find the KNN, or just use Pythonic or your statistics method, or just use your knowledge of machine learning to just understand what might be the best way. So using these stats only, we are calculating the best way. That is the correct way. Are we clear? Are we clear? Okay. And we already know all of these parts. How to do the prediction. I have already made this part before. Okay, I told you this part before. Yes. So if you want to run it here, now what we will do, we will copy and paste our model code. Where is our model code? Yes. So before this predict function, because it requires KNN, we will select a value of k. What is the value of k we will select? Let's select 8 because it was giving us the larger number here. We trained the model, we predicted the model, this is a function. Now we will do the prediction. This is our prediction, right? This is our prediction. And if you want to predict everything, then what are you going to do? Just iterate over all the values of x. Iterate over all the values of x. For I in x, you will get all of these values. These values you are going to pass into this function, which is going to create you the predictions. This is your prediction. In predictions, you are adding the prediction and prediction index, whether it is 0, 1, 2. We have 3 classes, 0, 1, 2. We are going to have here. So we have predicted everything in this index. And what I want to do, I want to create the final data frame. Do we have the actual data frame? Yes. This XDF copy, which we created at the very start, which is nothing but the copy of the data frame. See what I'm doing. I just want these predictions to be saved as a new column. In new column, I'm saving all of this prediction. In new column, I'm saving all of this index of the prediction. And once both of them are done, I can just save them as a CSV. So CSV, you guys can check side by side as well. Actual was 0, model predicted 0. What is that? Did I wrote something else? Predictions type. Where is it? Oh, did I? Oh, everything is wrong. Better now. But now it is going to create things again. So, okay, so let me run everything again and delete it. It will not take long. Oh, I could have just clicked on run all here and it will run everything. So if you guys want to do side-by-side comparison, you can always open it and you can see the actual was 0, model predicted 0, actual was 0, model predicted 0. You will find some of the cases where actual is 0, model predicted 1. That is the wrong predictions. Okay. That is the wrong predictions. You can also find that. And how do you find the wrong predictions? Using confusion matrix, you guys can also check it. If you want to check the confusion matrix, this is via confusion matrix, which again I have to import. Just wait for the confusion metric. Ah, yes. Okay. Y test, where is Y test prediction? Where were we predicting everything? We didn't. So now I'm going to predict the data here. Just wait, guys. Give me a second. The prediction part is present here. Okay. This same KNN, I want to pass X trained scale, and I will get Y trained, and I can also get Y test prediction KNN. Okay. So if you want to check in the test case which of them were wrong, we can just pass Y test and Y test prediction, and we will get the confusion matrix. Okay. Everyone knows how to read confusion matrix. Diagonal ones are the correct ones. Anything other than that, it is wrong. So what is the accuracy we are getting? The final accuracy with k equals to 8, we are getting it as 96%. Line 83, guys, where is line number 83? Ranga, what is line number 83? Here you are saying 83. Here it is different. Line number, oh yes, it is 83. Okay. Actual was 1, model predicted 2. So you guys can check it. So this covers our cross validation. Okay. Guys, we have done a lot of dry run coding also. Everyone should do coding like that. So we have covered multiple ways to find out optimal value of K and KNN. Is everyone clear with this one? Guys, are we clear? Are we clear? Now these two are nothing. We already have the data set ready. We have already done the transformation. We will just pass into SVM. I will show you linear, polynomial, and RBF. It is just a parameter. Then I will show you hyperparameter, which will not take time. Okay. So we have covered the biggest part that we will be using in other two concepts as well. So guys, did you like today's class? At least the half part of it. It's already 9:15. Enjoyed? Practical? But you guys are not doing your part. That is the assignment which I'm giving to save the model and other things. I will share the notebook, guys. Good. Enjoyed? Same thing, guys. Concepts, once we cover the concepts, everything is very simple. Don't worry, a lot of things are still left. Okay. Let me give you all of this file. Guys, I'm sharing the file. Don't worry. It is October 26. Okay. I have shared this file. How is accuracy calculated in confusion matrix? Sayyad, confusion matrix consists of true positive, true negative, false positive, false negative. Accuracy also have a formula with true positive, true negative, false positive, false negative. Write it down for the interview. Okay. Accuracy actually gets calculated from these values. All we see is a final value. Sure, Lalit, I didn't see it. I will take a look at it. Okay. Sorry about that I missed it. So let me save this file. Downloads. It's 26, right? Okay. I'm sharing the document. And guys, class is not over. Don't think like the class is over, okay? All right. Baiju, after machine learning, everything will be very fast. Because as you know, guys, I'm starting the break now. You guys can go on break. I'm starting a timer. 20 minutes. And please come with full energy. We need a lot of things. Start it. Welcome back, everyone. I hope you guys have done are done with dinner, breakfast. Welcome. Yes, welcome back, guys. Welcome back. Right. Ready? Feeling energized? Yes, great. All right. So, what is the next topic? What is the next topic? I hope you guys didn't forget it. What is the next topic? SVM. Correct. So the next thing that we are going to start is support vector machine, the practical part of it. Okay. I'm going to do in the same file. You guys can later separate it. I'm going to rename it. Instead of KNN, I will say KNN SVM. Okay. Support vector machine, SVM. So very simple. As you all know, apart from the concept, everything is very simple. It's machine learning. Everything is already implemented. So first we are going to import support SVC. Okay. What is SVC? Support vector classifier. Because we are doing classifying. Support vector machine is the algorithm name, but we are doing what? We are doing classification. So it is support vector classifier. Is everyone clear? Are we clear? Okay. Now see this part. Next, I want to create a model. Support vector classifier. Kernel, I am selecting it as linear. Do you guys know what is C? How many of you know what is C? C was the regularization parameter which we were adding, kind of a penalty regularization, whatever you guys called it. When we add a C, it is a soft margin classifier as well. Yes, correct. It creates a soft support vector machine. Yes, do you guys remember? And random state is just random state. This will give us a model, let's suppose linear SVC classifier or SVM classifier. Similarly, we have a polynomial as well as RBF. So instead of creating something like this, I want to loop over multiple models and get the answer. So instead of creating a line like this, okay, now I can train in a single go. I am creating a dictionary. Inside dictionary, the keys are just the string name, what is linear, and the value is the object of SVC. This is linear. When the kernel is poly, it will become polynomial. When the kernel is RBF, it will become RBF. Okay. In polynomial, we can mention the degree. Polynomial of degree 2 creates 3 values in 6 dimension. Degree 3 will create something else. In RBF, we have something called as gamma. We don't have to worry about it. As I told you, RBF converts things to how many dimension? RBF converts things to how many dimension? Infinite dimensional space. So whatever unknowns you will be able to find, don't worry about it. It is a scale. Internally, it uses a lot of the formula. It has only two values. It has only two values. If you check, go to the definition. This is support vector classifier. C support vector classification. We have C, we have kernel, linear, poly, RBF, we have sigmoid. There are a lot of things, but we only need to care about those more important ones. See, by default, it is already RBF. Degree, okay, degree of the polynomial. If you want to select gamma is scale, okay. Scale only has two values, scale and auto. By default, it is already selected to scale. All right. So we are just passing scale. I will talk about why I want to show you this gamma or gamma because later I want to change it. Is this part clear what I just did? In a dictionary, key and value pairs, I saved the string name with their respective object. Very simple. Now I can do model fit by iterating over this dictionary. Yes or no? I can do my model, multiple model fit by iterating over this dictionary. And that's what I'm going to do. Very simple. So what I'm going to do, in this for loop, let me zoom in. In this for loop, I am going to iterate. I already have my scaled models, X trained scale data and Y train. I'm going to do model fit. Okay. Once the model is fit, I will do the prediction. Model dot, this is the model. Model dot predict X train scaled, and it will create a Y train prediction. Similarly, I can get Y test prediction as well. Yes. Y test prediction. Then what is the next thing? We can calculate the accuracy of both Y train and test. Train and test. So train accuracy, test accuracy. Then what we can also do, we can append all the results in a list. So this is a result. And what I want to append, I want to append what is the name of the model, what is the training accuracy, what is the test accuracy. This will be a single list. So inside this list, I want to append another list. So just like this one, this will be a model number 1. Then by comma, we will have model 2 values. So 0 index will be model 1, second index will be something else. Are we clear what I'm going to do? So result, and then in this result, I'm going to append the name, train accuracy, test accuracy. See this, done. Then we can also print it. What is the train accuracy and test accuracy? So currently I'm printing the current name and current train and test accuracy. And I want to differentiate multiples by this separating line in the print statement. When I print it, is it performing? Is one of the kernel performing very better than the KNN? Can we see 100% test accuracy? 97.5 is on the train, but test is 1. It is performing on linear. Guys, what we do in linear? Linear, the kernel transformation value of linear is k is the function. It accepts x1 comma x2. What it does with x1 comma x2? x1 multiplied by x2 finds the similarity. Very simple function. Yes, multiply. Yes, this is all of the small details is what you guys need to remember. Only the small details. No one will talk about how actually things are working. Just small things for the interview. Okay. This is with linear, SVM, and other things. Now tell me, I can also convert something like this. Okay. Just wait. All right. Okay. Now tell me, is this the correct way to test the accuracy, or do we need to change something here? Linear in parameters, Shiv, always. Linear in their parameters is what linear is. Guys, is this the right way to test the accuracy? Is this the right way to test the accuracy with a single train and test? With a single train and test? No, we should do cross validation. So what I'm going to do instead of something like this, okay? So let's validate with our cross validation. Validation with cross with CV across SVM kernels. See this, very simple. Introduce CV. Yes, we will introduce the CV. It will be very simple thing. So see what I'm doing. In kernels, I'm writing kernel poly RBF. Okay. Then CV results, I'm going to save it into a dictionary. I'm going to iterate over this particular linear. And you guys know what I'm doing. For linear, then we are going to have CV folds. Yes. So first, from this linear, we are going to create a kernel of this one where the C value is 1, gamma is scale, random state equals to 20. Even though linear will not use this gamma, but this is a main object, right? This is a main class. Internally, it will not use this parameter, but we require this parameter for RBF. Yes or no? Are you able to understand? This is a common argument. Whether the class uses it or not, it's not of a problem. And we should also code like that, that it will work for all the cases. This creates a SVM. Now what we will do, this SVM we will pass to, guys, degree is already there. A by default value of degree is also there. It is already default to 3. All right. So I'm not passing this time. Otherwise, if you want to pass something like that, you can create a condition for this SVM object. If it is linear, pass the degree. If it is not, something like that. Yes. How many of you can do that? If you want to create more custom object. Easy? Easy or not? It is easy. Okay. Now this SVM object, we will pass to cross validation score along with the data. But instead of passing X train, we can pass what? Which we were passing previously. Where is the data? Cross validation. Guys, let me look for the cross validation. Here. X scaled comma Y. Our original data. X scaled comma Y I am passing. I am saying cross validation fold of 10. Scoring accuracy, I passed SVM. Simple. Then I will calculate the score dot mean, and I will save to CV results under what kernel name? Under the kernel name of linear. Because we don't have a concept of K, we don't require to save all the values of K. Only the kernel and what is the mean accuracy. And then we can just print it. If you guys want to print it, you can print it like this will be the linear in capital 1, linear SVM, mean CV accuracy is this one. Sir, should we not pass Y train for CV? This is why, Shiv. See, guys, why I'm passing the whole? Because I can. Okay. Because internally it will be doing a lot of different splits, which will give me a good result. The main part test, what we are doing now, we are trying to find out the original value. More data we have, the more I will be able to understand it. That's what I am doing. You guys can use train and test it also. But idea of ML is to not see the train. Shiv, who is teaching you all of this? Guys, is this statement set in stone? It is to train the model. Now tell me, guys, I taught you multiple times. I have the whole data. I have the whole data. What I want to do, guys, what is the point of splitting first? Tell me. What is the point of splitting first? What is the main point of splitting? Tell me the main point of splitting. Training and testing. The main point of is we are splitting because we want to test on the unseen data. We are splitting because we want to test on unseen data. That is the main thing. It's not because of train and test. It is because we want to test on unseen data. Is this part clear? So if that is the goal and we only have single data, then we require train and test. Now suppose in train you got 97%, in test you got around 96.5% accuracy. The model that is created from the train, are you going to deploy this model? Or you are going to deploy a model combined with all the data? Because in the production, there is nothing to test. The production data itself is the test set. So this will be the final model or this will be the final model. I'm talking about the production. Okay. But if you have lots of data, then always keep some kind of a test set and never mix with train. Because let's suppose this is model number V1. This is model V2 with all the data. Let's suppose tomorrow you are getting more thousand of data and you want to train the model. And again, you want to test on the test set. So in those cases, you will never merge it. So there is no rule like you have to do this. It's all what you want to do. Is everyone clear? Sir, what I meant was that CV on whole Y might overfit. Guys, CV on whole Y will overfit the data. Tell me, CV on whole Y will overfit the data. Tell me, CV on whole Y will overfit the data. You are missing the concept again. This Y will be splitted into multiple folds, and each of these folds create a different model. No models share the data between each other. If model were sharing the data, then it means data leaking. Internally, these splits are not shared. Guys, please, okay? It's totally fine, but this concepts you should not it's okay to ask doubts, but always remember the concepts. Is everyone clear? Shiv, are we clear? And others? Great. Okay, ask doubts, but also try to make sense of the main topic. Okay, it's totally fine. Yes. So always create your own rules based on what you where you want to deploy, how much data that you have. You are the data scientist. If data scientists will work on rules, we will be statistician. Rule 1, do this. Rule 2, do this. We will be kind of a robot. We can use our own thing. Always make sure that you look at the data, look at the consequences, look at the topic which you're working on. Okay, so this part is done. Let's run it. So each of the scores which we will get is not from a single test set, but a multiple test set. Now, which model is performing better? Guys, why I'm using .4f? It is just to format my print statement. It means I want a precision of 4 digits. It is just to format. The actual value is here. This is just to format my print statement. Point precision. If I remove it, you will see the whole precision. This is just, I don't want to see all of these numbers in my print statement. Are we clear? So here I can see linear and RBF are giving me the same result. Yes, previously linear and RBF were very different. Are we clear? Let's suppose I want cross validation of 5 only. Then you can see only this value is changing. Only 2. Then this value is improving because we don't know how the randomness is working. Okay, there is nothing like cross validation split of 2. That's why let's see 20. And 20, you can see this one is still stable. We are seeing a little bit difference here. So it's totally up to you. Try with multiples. If you're okay with 10, I think these two numbers are very close to each other. And also it's not like this poly SVM is bad. Poly SVM is also performing very well, right? Only small difference is there, but 2% accuracy means a lot in some of the cases. Are we clear? So how to select something good from here? We can use the CV results. We can use a dictionary. So we want to use the max from CV result and get this max value from the key of get CV results.get. This will give us the best kernel, and then we can print the best kernel. Best kernel by cross validation is linear 0.9667. Why it is 0.9667? Why it picked this one? Because if we remove the precision, let's see, this one is little bit higher. Are we clear why it is giving us this? Everyone? Are we clear? So we have completed SVM as well with multiple kernels. See, is implementation hard? Is implementation hard? No, implementation is very easy. Is the concept hard? Concept is the hardest thing to understand. Obviously concept we have covered, so now we know all the news and all the points of that. But now previously it is very hard. Implementing is easy, but understanding the basic is the main key. Yes. Thank you very much, guys. Thank you. I think with ChatGPT implementation is much easier than before ChatGPT. Nishal, you can say so, but all of this, if you even search on Stack Overflow, you will find different points here and there. Machine learning with sklearn was always looking the same. Okay. But yes, now it is easier because we don't have to look on the documentation a lot with all of these things. But always remember this part. Yes. That if you want to know more things, but I would suggest never go there because a lot of the optimizations are here. Okay. That will scare you. Coding is easy, but the concept is hard to understand to get the code everywhere. Correct. So we have also covered the practical of all three. So what is the next topic? What is the next topic? Hyperparameter tuning. Okay. Main topic is hyperparameter tuning. So let me talk about hyperparameter. It is nothing to be scared of. Okay, but it is a very powerful tool. It's not a concept, it's a tool. It's a Python programming thing. Okay. So currently we are talking about hyperparameter tuning. How can we correlate SVM concepts like classification of data, fitting the line? It does fit the line, Niranjan. It separates the line. It separates different groups of data. Same thing. Just like classification, guys, logistic regression and SVM do look like same thing. But how it is creating that line is little different. In terms of code, uh, the code is also same. Niranjan, what exactly I should answer? Okay. If you can formulate that, it will be better. Okay. So guys, please focus on the hyperparameter tuning. It is very good. So guys, what do we mean by parameter? When I create a function called as add, my arguments are nothing but the parameters of this function. Yes or no? These are nothing but my arguments. We call it as arguments. But these are arguments of a function. But if I talk about parameters, okay, if I talk about the parameters, let's suppose I'm saying something like a machine learning algorithm, okay, a machine learning algorithm where W new is equals to W old minus eta, that is learning rate, times the gradient. So what is the one parameter which I can configure here? Tell me. Configurable things. Configurable things. If I talk about the configurable things which I have to set, the first thing is going to be learning rate. It is true that we also need to set the weights and bias at the start of the algorithm also. Yes or no? But if you see in later cases, the class, when we create an object of linear regression, it handles all of this automatically internally. Yes or no? So in case of libraries, what will be the only parameter which we need to change? What is the only thing which we can change? The eta or learning rate, because it handles it internally. It is not in our control. It is, there are arguments for it, but what is deciding from us, deciding factor is learning factor, learning rate here. So things that we change to enhance the performance or degrade, because of that the performance get degraded, those are called as hyper parameters or just the parameters. What is my parameters of model? Are we clear? Are we clear? So if I talk about SVM, what are the parameters which we have learned? We have learned C. We have also seen something called as gamma, and we have seen kernel. These are the things which we need to set, and setting this rightly or wrongly affects the overall performance. Yes or no? Affect the performance. So these are nothing but called as parameters or hyperparameter. Okay. Are we clear? So the topic which we are doing is called as hyperparameter tuning. It's about tuning something. If I want, and let's suppose I'm talking about brightness of my screen. Brightness of my screen. So the current brightness depends on what exactly I want. If it is night, I want to decrease the brightness. So night is the goal. That means the accuracy part. So brightness, I will be moving it here and there to set accordingly. So what I am doing with the brightness slider, I am tuning it. Yes or no? I am tuning it according to my need. Are we clear? I am tuning it according to my need. So what I really want is, I want to tune my SVM based on parameters, and I want something kind of a slider for parameter. I don't know which value gives. Do you know that C equals to 1 is the perfect value? Do you know C equals to 1 is the perfect value? No. Do you know C equals to 0.1 is the perfect value? Or C equals to 100? If I tell you, what you will do, you will train the model with C equals to 1, C equals to 0, 1, and check which one is giving you better accuracy. Yes or no? Then you will select one. Once you select something, next thing what you will select? Next thing you will check when keeping the gamma is equals to scale or auto, which one is giving the better accuracy when C equals to 0.1? Let's suppose scale is giving. So you will again create two models, check the accuracy for only C equals to 1. Then you will check for multiple kernels, which kernel is giving us the best accuracy. So are you able to see there are lots of parameters just to get a single best model? A single best model can have C equals to 1, auto, and kernel equals to linear. But we need to try multiple things to get the best model. So what we want to do? We want to tune the hyperparameters. Are we clear? Is everyone clear what I'm saying? We want to tune the hyperparameters. Guys, are we clear or not? Only 2-3 people, others are sleeping. Great. And it is not that hard to implement. Guys, can you create your own class, something like this? Yes or no? You can create your own function. It is nothing but how you want to do it. As I mentioned, it's a tool. It is not a concept, it's a tool. Okay. So next topic is hyper parameter tuning. Okay. See this. One of the tool available is from sklearn is grid search CV. CV means grid search CV. Okay. You can check exhaustive search over, and the grid search, the CV itself is grid search CV automatically provides you cross validation internally. Are we clear? It already has an argument for cross validation internally. So I will show you that. Let's import it. Once we are done with importing, then we will create a grid. Let's create parameter grid. This will be a dictionary. What is the first parameter which we need to tune? C. Let's create multiple values of C. 0.1 is one of the value. Let's select 0.5. Let's select 1, 2, 20, and 100. All right. I think it's something is wrong here. Oh, it should be equal. It is a dictionary. Next is what parameter we want to do? Gamma or gamma. What are the values of gamma? We already know. One is scale. Guys, this value should exactly match with what algorithm is expecting. So what are the values? Capital C. In lowercase gamma. In lowercase, what is also expects? Scale. Yes. Degree. Degree is also there. Scale is also there. Yes or no? So I'm going to keep it short. Make sure that you are taking the same as it is arguments which is present here as the key here. That's why it is capital C, small gamma. Is this part clear, everyone? Is this part clear? Everyone is sleeping. What is going on? After gamma, what is the last thing? What is the last thing? Let's select kernel. We can do more, but I just want to tune only these parameters. Let's say linear. Let's say RBF. Let's say poly. It was poly. Okay. We can do more. Let's select the original one and see how many others are available. No, Nishal. It is not deep learning. In deep learning, it takes time. In machine learning, it does not take time. Where are other values? Kernel, linear, poly, RBF, sigmoid, and let's select till sigmoid. Okay. We don't know sigmoid, but still we can pick it. Yes. Linear, poly, RBF, sigmoid. We are creating this grid. This is the grid. In this grid, we are going to search for the optimal one with the cross validation. So this grid is completed. Now I'm going to create this object. Grid search CV. I'm going to pass my model. The first argument is the model itself. What model we are going to pass and the parameters of this model. This whole dictionary we are going to pass. That is the parameters of the first argument. That is nothing but our model. We are passing the cross validation C. It is automatically an argument of grid search CV. We are not creating a new cross validation. It already has an argument for it. We are saying it as 10. Scoring we want as accuracy. N jobs. N jobs means how many multi-thread and processing we want. -1 means set automatically. Are we clear? Are we clear with -1? Guys, do we need learning rate here? SVC takes care of that internally. Yes. All right. So we will create an object. This will create the object. Let's save it into the object. Sir, what does set automatically mean? Does it set to auto scaling? Where is auto scaling? No, scaling is a different concept of RBF. Guys, RBF is very mathematical. Just as I mentioned, whenever it is being asked in the interview or for your own intuition, kernel is something which transforms your data into other dimension. And in those dimension, it finds the similarity. And the points which are similar creates a group. Points which are not similar creates a different group. And it creates a plane between them. Okay. If you talk about n jobs, it is creating for different. Guys, see, we are doing for different processing. We are doing multiple model training. We are doing multiple model training. Model 1, model 2, model 3, model 4, model 5. Let's suppose we have all the way till model 100. If I wait for in sequence, Then once this model is completed, then I will train this model, calculate the accuracy, then go here. How many of you remember the concept of multi-threading and processing? When this process is going on, when it is waiting for input and output bound of thing, we can start M2. But when it is not waiting for that, we can create a new multi-processing. M1 will go, M2 will go, M3 will go, all of them in a single go. It will be trained parallelly, yes or no? So that is what n job is. We don't want to say how many processes to create, 3 or 4. We want to say whatever is ideal according to our system, it will calculate internally. Select automatically. -1 means select automatically. See this. Guys, everything is in the documentation. I will show you. Go to definition. Let's search for n jobs. Number of jobs to run in parallel means -1 means use all processors. Are we clear? It uses parallel backend and other things, but internally it uses all of that. Are we clear? So it is because we have lots of model. See what it will do for each combination 0.1, it will train with a scale and all linear. See this. For single 0.1, it will do scale and it will do, let's see, I will show you how many models it will be creating. The first combination is, the first model will have 0.1, comma scale, comma kernel as linear. Now the same 0.1 scale kernel will create this 4. So this combination will create 4 model. Now 0.1 with auto will again create 4 models. So for a single value, how many models we are creating? 8. This one will create 8. How many we have? 1, 2, 3, 4, 5, 6, 7. 56 model it will create and test. Are we clear? Everyone, are we clear? And it will test which model is the best one. So that's why we require a lot of parallel jobs. So this object is created. Now what we need to do, this time I'm going to take a shorter data set. You can train again. If you want to pass whole thing, you can pass the whole thing to get the ideal one, because we are not doing a testing separately. See this. Let's fit it. It will take some time. See, the previous one was taking around 1 second. This one is taking around 2.8 seconds. All the models are trained. Now to check which model is best, grid search CV has some parameters like what are the best parameters? What are the best combination of parameters? When the value of C is 0.5, gamma scale, kernel is linear, we are getting the best one. If that is the best one, what is the score? If that is the best one, what is the score of the best one? We will get under best score underscore. We are getting 98% accuracy with a cross validation split of 10. So this model is the best one till now. Even if we check the previous one, we were getting 96 only. But we didn't do the hyperparameter tuning. Our C was 1. Gamma scale, even though this one is coming from linear. But now we know what exact value of C is giving us the best model. Are we able to understand the parameters which we can train the model? Now we will take these final parameters and train the final model for the deployment using these parameters. So it gives us the parameters for the best tuning. And this is what hyperparameter tuning is. All right. I just printing the same thing. You guys can see it here. Yes, Shiv, what? This is what I'm doing. Otherwise, what is the point? Okay. So this covers our hyperparameter tuning. So guys, in machine learning, hyperparameter tuning is not too expensive. It takes seconds, it takes minutes, is totally fine. But when we go to deep learning, the hyperparameter tuning for creating a single model in deep learning, sometimes when the data is large, when you work with images and other things, to create a single model, sometimes it takes 30 minutes. For when the data and the complexity increases, a single model might take 2 days as well. So if you have lot of parameters to tune, to get just the right parameters, you might require the whole week or the whole month just to train it. So we cannot hyperparameter tuning. We also do that, but we need more knowledge. That's where the experience comes in. I should not do that. I should not do that. The value should be in this range. The value should be in that range. That is something we should need to understand that time. Are we clear? Are we clear? But still, we knew here that we should pick a value between 0 to 1 for the ideal case. And indeed, we were able to find 0.5. If the value of C was around 100, then it means the concept that we will learn for the soft margin is failing. Is our concept failing? No, the concept is not failing. Are we clear? So this completes the main part which I talked for today's class, that is hyperparameter tuning. So guys, did you enjoy today's class? How did you like this class? We have completed the majority topic which I talked about. Too many things, but is it good or not? When to use CV versus grid search CV? Guys, grid search CV uses, if you have time, always use grid search CV because internally uses CV, but you need to understand all of those things. You can use your own CV. It's totally fine. If you want to try with multiple CV, then what you will do? Yes, if you want to try multiple CV, then what you will do? You will train with different CVs. Okay. So I'm glad you guys, today's class from my point of view is not hard conceptually, but because you guys are seeing a lot of code, that is where it is becoming a little complicated. Okay. So do you want me to teach more things? Everyone? Do you want me to teach more things next week? Vijay is excited. Aruna is excited. It will be a bouncer. We should good for today, next week. Everyone is saying next. Guys, see, I think practical takes a lot of time, and if I pick the single data set, then it becomes easier for me to teach. Okay. So from next class, what I will be doing is cover as much concepts as possible within a week or and then we will cover 2-3 algorithms within a single day for practical. This speeds up our class. Yes or no? Within this class, we are able to complete 2, 3, 4 more topics implementation wise. But if I do concept implementation, it is taking a lot of time. Because again, I have to revise all the parts and it is not good. So what I will do within next week, I will cover 3 machine learning algorithms. If you are able to complete that, let me check the syllabus. Just give me a second. Okay. I hope everyone is able to see my screen. Only 4 ML concepts? I don't think so. It is a big module, guys. Machine learning is the main module of this course. After this one, everything is going to be introduction towards that specialization. But machine learning, we are completing as a specialization. We have completed, I will talk about this naive-based classifier. It is very simple. Everyone knows what is the Bayes theorem. We already covered in statistics. Yes. Naive Bayes classifier, that is only one thing I will talk about. KNN regressor. KNN classifier we already know. Yes. KNN regressor does what? whatever we are classifying with the nearest neighbor, when it is in case of numbers, regressor will do what? From those neighbors, it will do the average and provide the answer. That is the regression. Instead of taking the majority wins as a voting, what regression will do? Regression will take the average of its neighbors and provide the output. That is regression. Are we clear? Same concept. Instead of majority, it will be the average of the neighbors. That is regression. And so this part is done. This is done. And what else is SVM we have completed? SVM kernels and other things, logistic regression. I think we learned in data imputation, yes, we learned in data imputation about those parts, right? Logistic regression, this part is also completed. Linear regression, mean MSE, R square, adjusted R square, I just showed you. Regression with OLS, but see, when I feel like I need to change some part of the syllabus, I will introduce it. I told you something more advanced than OLS. Yes or no? Is OLS part of the syllabus? OLS is not part of the syllabus. OLS is part of the syllabus, but gradient descent is not part of the syllabus here. But I told you that because that is very important. So whatever I feel like I have to add or remove, I will keep on doing that. But I will cover the majority of the all the important things asked in the interview. All, not the majority, all the important things. Okay. Bayes theorem, we will be covering. What is DT and RF, Joshi? KNN, decision tree. Okay. What we will be doing next week is Bayes theorem. It will take half a day. Ensemble methods we will be starting, but before ensemble methods, I think we will be covering decision trees. Okay. Decision tree. But need to check what decision tree I will complete. See, SVM is here. SVM we already covered. Yes. I think who was it? Someone told that only 4-5 algorithms. Yes. So Coyote was right. We only have 4-5 machine learning algorithms. Then our machine learning part will be over. Machine learning is the biggest part. Then most probably I will do some kind of resume discussion or how to create resume so everyone can prepare for it. Guys, if you don't remember anything of this 12 modules, or if you're not ready with all of this 12 modules, trust me, it is going to be very hard. Okay, guys, we have completed almost 8. How many months has been? It has been 8 months, 7 months. How many months? Is it 6, 7? So we did completed a very huge amount of topic within 7 months. If you check the details in which we are learning everything, 7 months to me feels like a good number. Yes, we are learning everything in very detail. If no detail, then it can be completed within 4 months, whatever we have done till now. So it is for your own good. Okay. So I think our speed feels good till machine learning. After machine learning, everything is kind of the beginner level of the specialization, which can be completed very fast. The algorithms are not too huge. Then the Gen AI part will come as well. Guys, don't try the job for ML now, because there are decision trees are the main factors of machine learning. So everyone uses that. Okay. So guys, we are done for today. And I'm raising a poll. You guys can. Pankaj, curriculum is there in your overview. Please check it. Always have a habit of checking your dashboard. Okay. Guys, is the 3 by default number? Because I do get 3s as well. I'm not able to see the feedback, but is 3 the by default something like that? There should be a feedback for Zoom platform, Lalit. Uh, that is a separate Zoom thing. Okay. No, sir, nothing is selected by default. Okay. So I do get 3s, but still I do get a lot of good things as well. So guys, be prepared in the next week. It will be very complicated because we'll be learning concepts for the whole week, because we want to complete things as soon as possible so that we will jump to more advanced things. I hope everyone is able to understand and you guys will cooperate with me as well. Practicals, as I mentioned, is never hard. Practicals is never hard. Concept is what is the main thing. Okay. Yes, that's great, Ashwati. Ah, what 1 star? Lot of 3 stars in this class. Guys, theory will be boring, but theory will give you the base. But when we will do the practical, we will do the practical in because unnecessary we are what should I say? Delaying this module, this whole part. It will be boring, but guys, it is for job, okay? It is not for Netflix. I understand, but I will make it as fun as possible. And trust me, this line part will soon be gone because we are moving to the decision trees. So it will be very different. Just one question as a beginner. In this course, deep learning is going to cover some part of CV as well. KK, I do think so. It covers computer vision part as well. And how many of you Python code plays? Guys, I'm giving you Python code. Okay. How many of you have seen the new project which I uploaded in the Udemy computer vision? How many of you have seen that? The new project which I added in the computer vision course, it is already added. It is around 5 and the image search, correct. I will show you now. Just give me a second. Okay. October 26 live KNN. Guys, please rename the file. I will rename the file in the Google Drive, but not here. Okay. You share the complete course as well, free of cost. Yes, I did shared. And if you guys don't know that, I will show you that. Okay. It is very good. From my point of view, in Udemy, like updating the very complicated things is going to reduce the course. What should I say? Not everyone will be able to. Guys, link is expired. Okay. That coupon is expired from very long. Just wait, I will show you. Share the full content earlier notebook. Guys, I did share the full content. Rakesh, this one has the full thing. If you want, I can change the name as well. No, guys, PDF. Let me share the PDF. I think after the break, we have not completed anything new. Just give me a second. Yes, replace it. This one is done. Let me rename this file as well to knn-svm- grid search CV. Okay. Guys, I'm sharing the file again. And please, someone, please upload on our community. Pankaj or anyone can do that. Anyone. And I'm also sharing the PDF. I did it. Okay. So guys, let me share my screen. I hope everyone is able to see this. Yes. So this is the new section number 12, which got added. Okay. This is YOLO powered image search. YOLO is algorithm of computer vision. You will understand it in one of the object detection part. You can see in object detection, you will see YOLO V11. So those explanation is there, but my part was to create a project, and you can see this is about project. So what I did is Siba, what happens even after planning? Do you think that plan always go with plan, Siba?